Hello, how are you? Family of telemathematics. Welcome to a new video of our channel. So let's get started. To begin with, we will perform an activity. Solve the indicated divisions with real numbers. Literal A. 714 divided for 21. In this first case, we have the quotient of natural numbers, so the result is 34. Literal B. Minus 648 divided for minus 12. In this second case, we have the quotient of integers then. First applying the law of signs, the result will have a positive sign, and performing the division, it would be 54. Literal C. The quotient of minus 15 divided for 48 divided for the quotient of 75 divided for 16. In this third case, we have the quotient of rational numbers, but fractions. Now, unlike the multiplication, my recommendation is to transform the division between the fractions to multiplication, finding the reciprocal to the second fraction, and it would be. Some teachers indicate calculate the product of the extremes. That would be 15 multiplied by 16, and this product divided for the product of the means, that would be 48 multiplied by 75. But since the result yields large values, then the simplification for most students becomes somewhat complicated. Unlike the values we still have, then we proceed to simplify the 15 with the 75, and we would have 15 of 15 is 1 and of 75 is 5. Also simplifying the 48 with the 16, we would have 16 of 48 is 3 and of 16 is 1. Then the fractions are reduced to the multiplication of minus 1 divided by 3 multiplied by 1 divided by 5, where applying the law of signs the result will have negative sign, and multiplying numerator with numerator and denominator with denominator of each fraction, the final result is minus 1 divided by 15. Literal D. 38.74 divided for minus 14.9. In the fourth case, we have the quotient also of rational numbers but decimals. Then, applying the law of signs, the result will have a negative sign, and making the division, it would be minus 2.6. Literal E. 8 cube root of 80 divided for 4 cube root of 2. In the fifth case, we have the quotient of irrational numbers but with equal indexes. Then, we start dividing the coefficients, obtaining 2. We keep the same radical, and dividing the subradicals, we obtain cube root of 40. Now, cube root of 40 can be simplified, and for this, we can conveniently decompose the 40 in the product of 8 multiplied by 5. Then, applying the property of the radicalization that states that the nth root of the product of two elements is equal to the product of the nth roots of both elements, then it would be calculating the cube root of 8 we obtain, and solving the multiplication of 2 by 2, the final result is 4 cube root of 5. And finally, literal F. 18 fourth root of 125 divided for 6 square root of 5. In the sixth case, we also have the quotient of irrational numbers but with different indexes. We will begin equaling the indexes to be able to proceed as in the previous case, and for it, we determine the least common multiple between the indexes 4 and 2, that is 4. Then it would be 18 fourth root and 6 fourth root. Now, for the subradicals, first we divide the least common multiple 4 for the first index, which is obtained 1, and this result we place it as exponent of the subradical 125. and 125 raised to the 1 is equal to 125. In a similar way, we proceed for the second one. We divide the least common multiple 4 for the second index, which is obtained 2. And this result, we place it as exponent of the subradical 5, and 5 raised to the square is equal to 25. Then, as the indexes are already equal, we proceed to divide the coefficients, obtaining 3, and dividing the subradicals, we obtain 5, we keep the same radical, and the final result would be 3/4 root of 5. Very well. I hope you have understood the activity, and if you have any doubts, check the material again, or let us know to help you.
If you liked the video, I encourage you to give it a like, to subscribe if you haven't done it yet, and to activate notifications so you can see the new topics that we will be releasing, to leave us your comments, and to share it with your friends. Until the next video,